Hey guys, Dean Chase here with another geometry lesson for you. Hope everybody's doing awesome. Let's go ahead and get this thing started with the word of prayer. Dear Heavenly Father, I want to thank you for this day you give us, Lord. I want to thank you for all you've done. I pray you'll bless us with a good afternoon and just help us get everything done we need done and bless us with knowledge. We love you, Lord. In Jesus' name we pray, amen. Alright, you guys, so today we're going to be learning about how to use angle bisectors of triangles. This is lesson 5.3, page 310. So, remember that an angle bisector is a ray that divides an angle into two congruent adjacent angles. Remember also that the distance from a point to a line is the length of the perpendicular segment from the point to the line. So this line has to be perpendicular to find the length between this segment and the angle bisector. So in the diagram, PS bisects QPR. And the distance from S to PQ is SQ. So SQ will be perpendicular to PQ. Let's keep going. So our two theorems for the day, theorem 5.5 and theorem 5.6. Theorem 5.5 says, angle bisector theorem. If a point is on a bisector of an angle, then it is equidistant from the two sides of the angle. If AD bisects BAC and DB is perpendicular to AB and DC is perpendicular to AC, then DB equals DC. Those two lines will be equidistant. The converse of that theorem says if a point is on the interior of an angle and is equidistant from the side angles, then it lies on the bisector of the angle. So if DB is perpendicular to AB and DC is perpendicular to AC and DB equals DB, then the ray AD bisects BAC. Okay? So that's very important information, but that also makes today's assignment super easy. So let's go ahead and bust this out so we can be done for the day. Find the measure of angle BAD. BAD. They want us to find this angle measure. So what we have to look at is we have to look at these two lines. They are congruent. They're equal to each other. And they're both perpendicular to the lines they intersect, which makes AD by the converse of the, the converse of the angle bisector theorem says that if this line is equal to this line, this is the angle bisector, which makes this angle and this angle the same. So if this angle is 54, the measure of angle BAD equals 54. And that's all there is to it. Super simple problem. Let's go ahead and jump to the next one. The spotlights form two congruent angles. Is the angle closer to the spotlight area on the right or the left? Okay, what we know is these three spotlights form two congruent angles, meaning the distance between right here and right here, these are the same angle measures, which means that the distance from him perpendicular to here and him perpendicular to here are the same. So the actor is the same distance from both spotlight areas. So the actor is the same distance from both spotlight areas. Boom! Example 2 in the books. Let's keep going. Example 3. For what value of x does P lie on the bisector of angle A? So, for P to lie on the bisector of angle A, we know that BP and CP have to be equal. So I'm going to write that down. Let's go ahead and do the work. BP has to be equal to CP. So now we just plug in our information we have for these two things. And that's 8x plus 8 equals 3x minus 6. And then we just are simply solving this. So I'm going to say let's add 6 to each side of the equation. These 6's cancel out. X plus 14 equals 3x. Now, let's go ahead and subtract an x from each side of the equation. These x's cancel out. 14 equals 2x. Lastly, to finish solving for x, we just divide by 2. These 2's cancel out, and 7 equals x. Hey, I like this lesson. I don't know about you, but I like this lesson. So, let's keep going. Theorem 5.7, concurrency of angle bisectors of a triangle. The angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangles. So, it's interesting. Last lesson we learned about the mid-segments where they intersect. And now we're learning about the angle bisectors. So, if AP and BP and CP are the angle bisectors of this triangle, which they are right here, they bisect each of those angles, then you know that PD equals PF, which equals PE. Said that in reverse order, but you get the point. So the point where they meet, all these blue lines are going to be equal, okay? Which is really cool. All triangles work that way. That's pretty awesome. The point of concurrency of the three angle bisectors of a triangle is called the incenter of a triangle. The incenter always lies inside the triangle. Because the incenter P is equidistant from the three sides of the triangle, a circle drawn using P as the center and the distance to one side of the radius will just touch the other two sides. The circle is said to be inscribed within the triangle. Okay? So you can draw a perfect circle inside a triangle using the incenter. Okay? I guess that's really cool information to know. So let's keep going. Example 4. In the diagram, G is the incenter of triangle RST. Find GW. So they want us to find this, and we know that G is the incenter, meaning that all three of these blue lines will be equal. Well, when you look at this, the problem is finding the length of GW is kind of like, how are we going to do that? But if we take a look, we know UT and GT, and if we look right here, we have a right triangle, okay? And we know how to find the sides of a right triangle using the Pythagorean theorem, which is a squared plus b squared equals c squared, where a is one of the legs and b is one of the legs and c is the hypotenuse. So we can just plug this information in and solve for GU, which we know, since this is the incenter, will be the same as GW. So that's what we're going to do. We know that a squared, so a squared equal plus b squared, which is 12, equals c squared, which is 13, because that's the hypotenuse of that triangle. We're looking at this little green triangle right here, okay? So a squared plus 144 equals 169. Okay, now all we have to do is subtract 144 from each side of the equation. Sorry. My goodness, I'm all over the place. I'm actually on holiday right now, so I'm kind of like, I'm picturing just having fun. Not that this isn't fun. This is a blast. Okay, a squared equals 25. So to finish solving for GU, the length of GU, we just have to take the square root of each side. Okay, these cancel out. A squared A equals 5. So GU equals 5. So the length of GW would also equal 5, because GU, which we solved for it, will be the same as GW. That's the whole lesson, folks. I feel like that was fun. Wasn't too bad. Anyways, I hope you guys are doing great, and I guess I'll see you later. So, see ya!